All right, let's talk about the normal distribution. So, the normal distribution, or bell curve, is a bell-shaped curve that's symmetric vertically. The mean, median, mode are all equal, and so we end up with something that looks like this. And with the normal distribution, the standard deviation plays a big role, and so we start with something called the 68, 95, 99.7 rule, and that is as follows. Approximately 68% of the data falls within one standard deviation in both directions. 95% falls within two standard deviations of the mean in both directions. And 99.7% of the data falls within three standard deviations on both sides. So what I've done is I've created this picture to illustrate the rule. And what we're going to do is, for a lot of the homework problems, they present you with a picture similar to this, with 68, 95, 99.7. What I want to do is, for each of these blocks, areas, I want to put the percent that is contained in each of these. The reason I want to do that is when we get to some examples, like below here, it's easy to just say, if I'm looking for some amount between, say, here and here, just to add up the portions here. And so while you can't bring this to a test, you can easily construct it. So this is just a normal curve. We know, in fact, most of the questions even mention this rule, so we know that 68% is within one standard deviation, 95 within two, and 99.7, so that is within three. So that's illustrated here. So x bar minus one standard deviation, x bar plus one standard deviation. From here to here, so all of this, so really all of this is kind of shaded, x minus 2s and x plus 2s, x bar plus 2s would be from here to here, and same thing here. So this is only 99.7% from here to here, so 100% also contains this stuff on the end, and we'll talk about that later. So in order to figure out how much is in each of these regions, well, we know this is symmetric. This is 68 from here to here. 68 divided by 2 is 34. 68 divided by 2 is 34, so this is 34%. 34%. So what I want to do is figure out what percent is in each of these. Now, for these two, how do we figure that out? Well, we know from here to here, or here to here, is 95. 95. And this is 68, so we can subtract off the 68. So there is 27 in this one and this one total. Okay, 27 total percent. So since it's symmetric, we can divide that by 2, and you get 13.5% here and 13.5% here. Okay, and if you don't believe it, you can add these up, and it should be 95%. In fact, that's kind of how we work some of these, is by adding these portions. Okay. Well, we do the same thing for the next set of regions. We know that from here to here is 99.7. We know that this from here to here is 95, so 99.7 minus 95. We got to split that between both. Divide by 2. 2.35%. 2.35%. Okay. Now, this is only 99.7%, so to get this region, these regions on the ends, we have to do 100 minus 99.7. You get 0.3 Divide that by 2, and you get 0.15%. And again, you could add up each of these portions, this plus 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 this, and it should be 100%. Okay? I like to do that because in the questions that you're going to encounter, they will give you a picture that is not as pretty as this. For example, let's look at this one. Okay, so they will have a picture for you. It will be, I guess let's talk about the question and then I'll draw the picture they're going to give you. We're going to use this example to apply it to this picture, which will be less helpful. So the figure I'm about to draw will be a normal distribution for a new car. So the mean is 27,000, so that is going to be right here in the middle, 27,000. And the standard deviation is 500. So that means that one standard deviation will be 27,000 plus 500, which is 27,500. And then on the other end, subtract 500, that's 26,500. Okay, so that is one standard deviation, and I could use my colors, I guess, but you don't really need the colors. And then if I go another standard deviation, I add 500 to that, so 27,500 plus 500 is 28,000. Over here, if I subtract 500, that's 26,000. So the highlighting I'm using doesn't really matter. I just want to kind of put it back to what we've already done. And if we go one more standard deviation, that would be 28,500 and 25,500. This is actually, those numbers, this picture is already given in the problem. I'm drawing it out so you can understand where the numbers they give you come from. So, in this question, they want to know what percent is between 25,500, which is here, and 27,000. So what I can do is take the numbers that we have already put here. We know that's 34 and 34 and 13.5, 13.5. Those numbers match up exactly. I'm leaving off the percent because I'm running out of space. I can extend this, 0.15, 0.15. So those are the same numbers for any of these examples. So if you want, now that you've drawn this out, you can just carry that with you for the homework. Now, you can't take it on the test, so you'll have to be able to construct it yourself. But when you do the homework, you can practice when you start preparing for the test. So 25,500 to 27,000, that would be 2.35% plus 13.5% plus 34%. Okay, we're going to type that in the calculator. You might also notice that this is going to be 34, 13.5, 2.35. If this is symmetric, then half has to be over here. So you could also do 50 minus 0.15%. Okay, so let's see, 2.35 plus 13.5 plus 34, again, 49.85%. Okay. So, now we want to do more than 27,500. Okay, that would be adding up this plus this plus this. 13.5. Uh-oh. So the pen seems to be running out of ink. So Move to this pencil. 13.5%, more than 25, so plus 2.35 plus 0.15. Okay, add those up because it says more than, so it's greater than 27,500, whereas this was between two numbers. 13.5 plus 2.35 plus 0.15, 16%. Most of the time you're not typing in the percents part, you just put in this number. And then lastly, less than 25,500, that's 3 standard deviations, so that's easily seen as 0.15%. Okay. And that's basically what this section is. Now we got some other questions that we got to discuss, but that's the meat and potatoes of this department, understanding that picture. Okay, so again, to be able to draw that, I would recommend drawing that myself. And then we've got the z-score. That's kind of the last major topic in this section, so let's talk about it. So a z-score describes how many standard deviations a particular data item is above or below a mean. It allows us to normalize data. We can compare apples and oranges, basically. If we have an apple and an orange, we want to know which one is larger relative to the average apple or orange. We can find the average apple or orange and then compare what we have to that. Okay? So if we have a positive z-score, that means that the data item is above the mean. If it's negative, it means it's below the mean. And there's our formula. If you don't like this subscript, you could think of it as just z equals x minus x bar over s. I use the subscript because that's what the book does, and later on they'll use subscripts in some of the examples. So z is the z-score that we're usually looking for, x is the data item, x bar is the mean, we know that, and s is the standard deviation. So in these problems, you kind of just need to pick out what's what. So example 1, a set of data items is normally distributed. That has to be the case in order for us to use this formula. They say that the mean is 60 and the standard deviation is 8. And they want us to convert the data item of 40 to a z-score. So I always like to write down what I've got. If the mean is 60, that's x bar is 60, the standard deviation is 8, data item is 40, that means x, and we're looking for the z-score. So I use my formula. Again, if I don't want to use the subscript, I don't have to. So we are looking for z. X is 40, x bar is 60, and then s is 8. So 40 minus 60 is minus 20 over 8. Let's see what that decimal is. It's going to be something we can easily round. It will specify how to round if it wants you to round. Minus 2.5. So there's no issue with that, minus 2.5. That means that the 40 was to the left of the mean, which was 60. So that's our answer. They might say in the problem to find z sub 40, which means 40 is your x. So that's how they use the subscript. Okay, so z sub 40 is minus 2.5. So don't let that throw you off. It's the same thing. All right. Now, the other situation is, what if they ask you to find a score? What do I mean? All right. So scores on a test are normally distributed with the mean of 130. We know what that means. So highlight or circle or write down all the information they give you. Standard deviation is 26. Find the score that is 2.5 standard deviations below the mean. Now, I'm going to approach it one way. You can do it a different way if you like. But let's write down what we've got. X bar is 130. Standard deviation is 26. They want us to find the score. That means find X. If the z-score, or that is 2.5 standard deviations below the mean, that means that the z is 2.5, because 2.5 is 2.5. Below the mean means it's a negative z-score. Okay. So I threw this one in there because I thought it was a little tricky. That's often an issue. If it's above the above the mean, it would be positive. So what we're doing is we're going to plug all our stuff into the formula, z minus x bar over s. In this case, we have z, we have x bar, and we have s. We do not have x. We have to solve it for x. So minus 2.5 equals x, which I don't know, x bar, which is 130, over s, which is 26. So what I have to do is I have to solve this for x. So I have to use some algebra. All right, the first thing I'm going to do, see if this ink came back. Not really. I like to use different colors if possible, but we don't have to. So I'm going to rewrite this step. You don't have to rewrite it, but whenever I'm working these out, I like to kind of be explicit. So first thing I want to do is get rid of the fraction. So I'm going to multiply this by 26 over 1, because 26 over 1 and this 26 will cancel. But if I do that, I have to multiply this side also by, no, that wasn't supposed to happen, by 26 over 1. Okay. So 26 over 1 is just 26. Okay. 26 divided by 1 is just 26 times minus 2.5 is minus 65. And over here, x minus 30 over 26 and this 26 cancel. We have x minus 130. At this point, you're going to add 130 to both sides. And so we get x equals 65. It just so happens that minus 65 plus 130 is 65. Okay, so the score that is 2.5 standard deviations below the mean is 65. And that's pretty much it.